Hi, Matrix. Welcome back to the Q&A session. Nice to have you all with us. I believe that you have been doing some paper 2 work with Marilise, and this evening she had said to me that you were interested in doing some 3D trig and some Euclidean geometry, so that's what I have prepared this evening. Obviously, if there is anything, it is a Q&A session. If there is anything that you want to ask me, then you're very welcome to. Hopefully you've got a book and a calculator and a pen to write with. We've got question 7 up. This is something that's a question that came out of the past paper that you've been working through with Marilise. And it is the question on 3D trig followed by stuff on Euclidean geometry. So just while we're waiting for everybody to arrive, I would just like you to please read through question 7 because there's quite a lot of information there. And then we can start talking about how we're going to answer these questions. Okay. So again, welcome to all the matrix that have just joined us. Please start by reading through question 7. There's quite a lot of information there for us to get through. And then in a minute or so, we can get underway with these questions. Okay, Matrix, I'm going to start our lesson now, if that's okay. Hopefully everybody's had an opportunity to at least read what was in question 7 and read the scenario with which we've been presented. First of all, I would just like to point out to you that what you're looking at here is a sort of side view of an entertainment area. So they've said to us that CGFB and CGHD, those are the two rectangles. They are fixed walls, okay? They're rectangular in shape, and they are vertical to the horizontal plane. The horizontal plane in this case, like it is in so many cases, is the shaded area. So that's FCH. Sorry, that's not correct. It is FGH. And that has been shaded for you. So that's the horizontal plane. Then they have said that there are steel poles that have been erected along FB and HD to extend to A and E respectively. So what they are referring to here is this is the end of the wall, and then here is a steel pole, and then over here is another steel pole. Okay, and then they have told us that this triangular shape, so let's just highlight that in a slightly different color. This triangular shape over here represents the roof of the entertainment center that has been built. A few other bits and pieces that they've given us. They've told us that BC is X. They've told us that CD is X plus 2. They've told us that at A, this is angle theta over here. And they've also told us within this triangle that this angle over here is 2 theta. And in this triangle over here, that is equal to 60 degrees. The first question is really sort of quite typical of one of these types of questions where they ask you to express something in terms of something else. So before we dive in and we start talking about the question, I just want to speak a little bit about how do we know what rules we're supposed to be using in which situation, okay? So first things first, when you are working in right-angled triangles, you must use your basic trig ratios. So what I am referring to are your basic trig ratios from grade 10. So in other words, SOHCAHTOA. So if you are working in a right-angled triangle, and just put this down for you. So when you are working in a right-angled triangle, you are going to use SOHCAHTOA. All right, so in other words, the sine of the angle is equal to opposite over hypotenuse, or the cos of the angle is equal to adjacent over hypotenuse, or the tan of the angle is going to be equal to opposite over adjacent. Now, those formulae are not given to you on your matric formula sheet because they expect you to know them. All right, so you expected to know those off by heart. So if a triangle is right-angled, we always use SOHCAHTOA. If a triangle is not right-angled, that is when we use the sine rule or the cosine rule, depending on the information that has been given to us, right? So that's very important to point out because in this first question, 7.11, they ask us to calculate the length of AC in terms of x and theta. So in which triangle is AC a side? In which triangle is AC a side? Can anybody tell me?
Triangle ABC.
Triangle ABC, absolutely. And what do you notice about triangle ABC?
It's a right angle triangle.
It's a right angle triangle. Well done. Okay, 100%. And Luyanda, you also said so, triangle ABC. Perfect, all right? So side AC represents which side of the right angle triangle in relation to angle theta. Is it adjacent? Is it opposite? Or is it hypotenuse? AC is?
Hypotenuse.
Hypotenuse, absolutely. It's opposite the right angle. Okay, so we've got the AC is the hypotenuse. So that immediately means we've either got to use sine theta or cos theta. Now let's have a look at what they wanted us to do. They wanted us to express AC in terms of x. So in relation to theta, where is x, side BC, situated? Is it adjacent or is it opposite? Can you see that it is opposite? So opposite to theta is side BC, which they have called x. All right, adjacent would be AB. So now we have identified which trig ratio we're going to use because BC is opposite and AC is the hypotenuse. So which trig ratio am I going to use in this case? It has to be
Sine.
sine theta, indeed. Okay, and then that's exactly what I would do. So I would state here that sine theta is equal to opposite is x over AC, which is the hypotenuse. But because they told us that they want us to calculate the length of AC in terms of x, they are now asking us to rearrange this formula and make AC the subject. Okay, so that means I now have to swap places with my sine theta and my AC, which if you understand ratio will hopefully make sense to you. So therefore, AC will be equal to x over sine theta. Does that make sense, Matrix, or is there something that you want me to explain? Sure, you understand why I've been able to interchange AC and sine theta. That's not a problem for anybody. Okay, I'll take that as a yes. All right, question 7.1.2, right? Please, if there's anything that I say at any point that doesn't make sense to you or you want to know why I've written it that way, please do ask, okay? Question 7.1.2, they want us to calculate CE in terms of X. Okay, so now if we come over here and we have a look at side CE, let's highlight that for ourselves. Here is CE. And when you look at CE, the other thing that you notice is that side CE, oopsie, I haven't drawn that very well, but it doesn't matter. Side CE is also the hypotenuse, only now we're not in the same triangle anymore, we're in a different triangle. So side CE is the hypotenuse of triangle EDC. What do they want us to talk about here? They want CE in terms of X, all right? So we have to use CE and we have to use X. Side CD, which is X plus 2, is it opposite to 60? Is it adjacent to 60?
Adjacent.
Adjacent. It's adjacent, 100%. Side CE is the hypotenuse. So if we're using adjacent and hypotenuse, I've got to use the what of the angle?
Cosine.
Cosine, exactly, a CP. Okay, so that's exactly what we're going to write. The cos of 60 degrees, let me just move that out of the way, is going to be equal to adjacent x plus 2 over hypotenuse CE. Now, of course, we can't leave our fraction like that. I mean, we can see that it's out of 2 marks. This was also out of 2 marks. So there would be 1 mark for writing it in this form, and then another mark for making AC the subject of the formula. And again, here, there would be 1 mark for writing it in this form. And now, because they want CE in terms of X, they want us to make CE the subject of the formula. So again, I can interchange CE and cos 60, but I'm still not 100% finished. So if CE is equal to X plus 2 over the cos of 60, what is the cos of 60 equal to? It's one of our special angles. And again, something that you would be expected to know off by heart. Can anybody tell me what the cos of 60 is?
One over 2.
1 over 2, indeed. Okay, so now the way that I have written CE here, matrix, I have written it as a complex fraction. I'm not allowed to leave my answers as complex fractions. So I have to simplify that, okay? So x plus 2 divided by half, what is the rule when it comes to dividing fractions? I have to. No problem, Swelithe, welcome. We've just got started on this question, so you haven't missed out on too much. Can anybody tell me what I need to do with the x plus 2 over the half? What's the rule when I divide fractions, matrix? I have to tip and times. Okay, or keep, flip, change. All right, so in other words, dividing x plus 2 by half is the same as multiplying x plus 2 by 2. So your final answer would be that. 2 times x plus 2. And I suppose if you remove the brackets, that would be absolutely fine as well. You're going to see in the question later on, we're going to have to refactorize it again. But that's where that second mark would come from. Is everybody confident with that? Does that make sense? Any questions? Sure. Okay, let's move on then. Let's talk about question 7.2. I'm going to pop that down here. Another very typical question for 3D trig, show that the area of the roof, triangle ACE, so that's the one that I have highlighted in pink, is given by 2x times x plus 2 times cos theta. So in other words, here they have given us the answer. They want us to show how that answer has been obtained. So now immediately the area of the roof, okay, it's not a right angle triangle. So that means we need to use which rule? Can I use half base times height if I don't have a perpendicular height? I can't. Okay, so if they're asking me for the area, then it means that they want me to use the area rule. Okay, so here in the middle of the screen is the sine rule, the cosine rule, and the area rule. So this is the area rule, and it will be on your formula sheet. So that's this one over here with a little red star next to it. And when I work with the area rule, I am working in a side angle side situation. So in other words, if angle C is my focus angle, then sides A and B are the sides on either side of that angle. So in other words, if I now look at this triangle, which angle do we know something about? Do we know anything about this angle A over here? No, we don't. Do we know anything about this angle over here, E? No, we don't. We know something about this angle over here, and it's called 2 theta. So if I'm going to use this as my focus angle, I need to know something about this side, and I need to know something about that side, because it's got to be side, angle, side. And indeed I do. From 7.11, I know what AC is in terms of X and theta. And from 712, I know what CE is in terms of X. So I can use those answers in what I'm going to do over here. All right. So the first thing is identifying which rule you need to use. And the second thing is being able to substitute accurately into that rule. So in this case here, we would say the area of triangle ACE is going to be equal to half times AC times CE sine of angle C. Now I want to substitute. So I'm going to use my answers from 711 and 712 to help me. I'm just moving the screen up a little bit. Okay, so substituting into my rule, that gives me 1/2. AC is x over sine theta. So multiplied by x over sine theta times CE. CE is 2 times x plus 2. Let's put that over 1 so that we know what's at the top and what's at the bottom. Sine 2 theta. Okay, so matrix, there will be a method mark or a continuous accuracy mark for substituting into the correct formula. So there would be a mark for that. Now, there's 2 things that need to happen. First of all, we need to cancel down, all right, because we can cancel the 2 at the top with the 2 at the bottom because it's factorized. But what about the sine 2 theta over here? Who recognizes that? What do I need to do with sine 2 theta when I see it? Isn't that special to me?
Angle, we expanded.
Yeah, exactly. It's a double angle and it means I need to expand it. Okay, so again, that's also on your formula sheet, but you need to recognize it. I've got to write sine 2 theta as 2 sine theta cos theta. Okay, so that means I've got 1 over 2 times x over sine theta times 2 times x plus 2 at the top over 1 multiplied by 2 sine theta cos theta over 1. Okay, now matrix, I'm allowed to cancel down something at the top with something at the bottom. So I could do this. I can say 2 goes into itself once, and it goes in here once as well. I can also say that sine theta divided by sine theta is 1. Is there anything else that I can cancel down here? Don't think so. I think I'm done. All right, and now I should hopefully end up with the answer that they gave me. All right, so now I've just got to put things into the correct order. Okay, so remember we always put coefficients first and then variables second. So in the numerator, I'm left with 1 times x plus 2 times cos theta. So 2 will come first, then it will be x. Then I can multiply that by x plus 2. And then finally by cos theta. And then I'm going to go back and just double check, is that what they gave me? Yes, 2x times x plus 2 times cos theta. Okay, out of 3 marks. So first mark for subbing into the area rule. I'm fairly certain that the next mark would be for the expansion of your sine double angle. And then I think there would also be a mark here on simplifying. There's not going to be a mark on the answer because that was provided. How's everybody feeling? Thumbs up, thumbs downs, making sense? Any questions? Okay, thank you, Karabo. Thanks, Asipe. Okay, please do stop me if there's anything. Thank you, Rehomeditswe. Please do stop me if there's anything that you want to ask. All right. Okay, let's carry on with the next question. They've told us 7.3. Now they give us something. They say to us, if theta is 55 and BC is 12, calculate the length of AE. Let's go back and have a look at the diagram. So AE is a side in triangle ACE, the triangle we've just been working in. We know something about this angle over here. Oh, oopsie daisy. Let me just, sorry. That went way too big. We know something about the angle at C. So we know that that's 2 theta. And we see when we look at the diagram that opposite to theta is side AE, which is what they want us to calculate the length of. Remember, we know something about AC, and we've been able to define AC in terms of x and theta, which are things that they've given us. And we also know something about CE in terms of x as well. So by telling us that BC is 12, they're giving us a value for which variable? By telling us BC is 12, what are they telling us? What's equal to 12 exactly? Not BC, but what?
X.
X, exactly. So they've told us how long side BC is, and they've also told us how long side CD is. So we know that BC is 12, and we know that CD is 14. When we are working in triangle ACE, as we've already established, it is not a right angled triangle. So how do we know which rule we're supposed to be using? How do we know if we should be using the sine rule or the cosine rule in order to work out AE? Does anybody know?
I don't know because we have 2 lengths and the area of the so the area between the 2 lengths.
Okay, I'll take that as a no. When we are working with the cosine rule. The cosine rule only works in two situations. Either you have to know the length of all three sides, so side, 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 and then you can calculate an angle, or you can use it in a side, angle, side situation. All right, so in other words, if the side you want to calculate is opposite a known angle, and you know the two sides on either side of that angle, then you can use the cosine rule. The sine rule is a little bit different. Okay, the sine rule says a side over an angle, or the sine of an angle, is equal to another side over the sine of another angle. So in other words, you need to know either two sides and the angle opposite that side, or you need to know two angles and a side that is opposite one of the angles. In triangle ACE, we only know one angle. We know nothing about this angle here at A. We know nothing about this angle over here at E. The only thing that we know anything about is this angle over here, and it is opposite the side we are trying to find. I hope that what I'm doing is explaining to you why we have to use the cosine rule in this case. We have to use side, angle, side to get the side opposite the known angle. Okay, so we've established we have to use the cosine rule. So here's the cosine rule over here. What I'm going to do, Matrix, if it's okay, has everybody written down the questions from 7.11 and 7.12? I would like to erase them. Is that okay if I go ahead and erase them just to create a bit of space here? I'll take that as a yes. Okay. So hopefully everybody's written that down because we are going to need at least some of the information. Okay. Let's move this up here for ourselves now. Okay, so the cosine rule works as follows. This side here that's called a squared is the side opposite the known angle. So side little a is opposite angle A. So in this case, our little a is side AE. Our angle A is this angle here at C, this one that's called 2 theta. B and C are the other two sides. All right, so fitting the cosine rule to what we see here, we want AE squared. So 7.3, we want AE squared. That's our A squared. And that's going to be equal to the two sides on either side. So the one side is AC squared. The other side is CE squared, which we already know that we know something about, minus 2 AC CE cos, and then it's the cos of angle ACE. So now I've adapted the cosine rule to the letters on the diagram that I've been given. My next step is to go ahead and go and substitute in. Don't forget, Matrix, this is AE squared. So once we get to the end, we then need to take the square root of our answer. Okay, so now substituting in. Remember, what was AC equal to? So from 7.11, we know that AC was equal to x over sine theta. So that means that I can now write this as x is equal to 12. We established that, and they've told us that theta is 55. So AC is 12 over the sine of 55 degrees. And that needs to be squared. Does that make sense, Matrix? I hope so. Okay, then recall side CE was 2 times x plus 2 or 2x plus 4. Right, so we need to work out the length of CE. You can do that separately. We can do it in one go. It really doesn't matter. So if we want to work out how long CE is, it was 2 times and x was equal to 12 plus 2 like that. Okay, so that means it's 2 times 14, which means that CE would be equal to 28. Okay, so in this bracket here, I'm going to have 28 and I'm going to square it minus 2 times 12 over the sine of 55 times CE, which is 28, cos, I'm almost off the screen here, to theta. Let me just move things over a little bit and more into the center. Is that making sense? Are there any questions that you'd like to ask me at this point? What I could also have done here, and in fact, I think I should do this quickly before you write it down, is I know what the value of theta is. So I want to substitute that it's equal to 55. So I'm going to do that. I can then input all of this onto my calculator and take the square root. Is everybody comfortable with being able to do that? Do you know how to use your calculator to work out the answer and then take the square root? So in other words, at this point now, you're ready to pick up your calculator. So what you would do is you would press the open bracket, press the fraction button. At the top, you're going to put in the numerator, you're going to put in 12. At the bottom, you're going to press sine 55. Then you must remember to close the bracket. Then you've got to come out and close the bracket again and then square it. Okay, it's very important that after sine 55 that you close your bracket, because if you don't, your calculator will give you an error and it's not actually wrong. It's just because you didn't close a bracket. Then you're going to press plus brackets 28 squared minus 2 times, again, bracket, fraction, 12 in the numerator, sine 55 at the bottom, close bracket, close the bracket again, times 28 times the cos, and you can just put in 110. 2 times 55 is 110. Once you've worked that out, leave it on your calculator, and then you're going to press square root answer equals. And then I will wait for somebody to tell me what they got. $35.77. Me too, Karabo. I also got that as an answer. Okay, so I think we are correct. Everybody else, is it making sense? You're getting the same answer as Karabo. Okay, so 35.77 meters in this case. Oh, good, sweetie Claire. I'm glad you got the same answer. Okay, Michaela, you said yes as well. Good. I'm glad to hear that. Here it's out of 4 marks. So again, substituting into the correct rule would be 1 mark. I would think because we needed to calculate the 28, that would be worth another mark. Perhaps there would also be a mark on the 110 and then definitely a mark on the answer. in this case. Are there any questions, Matrix? How's everybody feeling? Thumbs up, thumbs down? Hopefully confident.
Ma'am, can I ask a question?
With pleasure, Leander, go for it.
Ma'am, so you see for the AC squared, right? In the
Yes.
beginning. When it came to the substance between like distance or whatever, how it's measured, like why is it 12 over sine 55 squared?
Are you asking Leander where that comes from?
Yes, ma'am.
Okay, so Leander, it comes from what we were doing in question 7.11. Okay, so we know that AC, sorry, and unfortunately I've gone and erased it now, but if you recall in the beginning, let me just rub this out of the way. In the very beginning, we had identified that side AC, let's just go back here again, side AC is a part of triangle ABC. It's the hypotenuse. So if you recall in the beginning, we had said in question 7.1.1 that the sine of theta was going to be opposite, which was x over AC. And then we rearranged to make AC the subject of the formula. So that means it became x over sine theta. Now in this question, they gave us a value for x and they gave us a value for theta. Okay, so I have gone and subbed those values in because they told me theta is 55 and x was 12. Does that make sense now?
Okay, thanks.
Okay, so that's why I've written AC as 12 over sine 55. Okay, no problem. I'm glad you asked. Are there any other questions, Matrix? Okay, I don't want to waste any time, but I obviously want to give people an opportunity to ask. If you do have questions, please do ask if there's anything else you'd like to know. Okay, so moving on to the next question is question 8 over here. Let me just make that a little bit bigger. Yeah, you can see that 3D trig is not worth a lot of marks. I mean, that was 11 out of 150, so it's not a huge section. But anyway, all the marks we can get along the way is brilliant. So we obviously want to be able to try and do that. Okay, so here's a little bit of Euclidean geometry. In question 8.1, they have told us that O is the center of the circle and that LOM is the diameter. So straight away, that's quite a lot of information that they've given us, because if we've got a circle center, then it means we could have angle at center is twice angle at circumference. Anything to do with a circle center, line from center perpendicular to chord. I don't know if we've got that in this situation. And then by them telling us that LOM is a diameter, which angle are they implying would be equal to 90 because of angle in a semicircle? If they tell us LOM is a diameter, which angle is 90? Indeed, Luyanda, the angle at P. So straight away, we know that this angle over here has to be a right angle. Then they tell us ON bisects chord LP. All right, so ON is this line over here, and it bisects chord LP. Also really important. Okay, so if the line from the center bisects a chord, then what can we say about angle N1 or angle N2? Also going to be equal to 90. Okay, line from center to midpoint of chord. Good. Yes, Luyanda, that's quite right. Okay. Then they tell us the 10 ESA points on the circle on the other side of LM with respect to P. Okay, that's over here. And then they tell us that there are different chords that have been drawn, PM, which we notice the same as MS. MT and ST are drawn, PM equals MS, and MTS. So this angle over here is equal to 31. One more question before we move on and look at the questions at the bottom. What other angle in this diagram is therefore also going to be equal to 31?
Angle M, ma'am.
Not angle M?
PLM, ma'am.
PLM, well done. Yes, I'm sorry. I beg your pardon. You're quite right. So PLM, this angle over here, that's also going to be equal to 31. What's the reason for that?
Angle subtended by equal sides, I think.
You're on the right track. It's equal chords subtend equal angles. Okay, good job. All right, so now once we've done all of this analysis, now let's go and have a look at the questions. So first thing, determine with reasons the size of each of the following angles. So first thing, MOS. So again, we go back and we look at our picture and we can see that angle MOS is this angle over here. Okay, so I want to work out how big MOS is going to be. What do you think I should do? How big is MOS? Anybody got any ideas?
It's double 31.
It is, indeed it is. Okay, so in other words, MOS is the angle at the center. And here at angle T, this is the angle at the circle. So the angle at the center is twice the angle at the circumference. Good, well done. So that means that MOS is 62. I actually don't think that's a very nice color to write with, I beg your pardon, is equal to 62. And our reason, angle at center equals 2 times angle at circumference. All right, so here matrix, statement, reason. And that was fairly easy. Good. Let's just move that up a bit. Okay, now they want angle L. Well, we actually already figured that out, haven't we? We've already figured out that L was equal to 31. So that makes life a bit easier for us as well. So let's go ahead and pop that in. So we've discovered that L was equal to 31, and we said equal chords. In fact, you can just write equal chords, equal angles, just like that. And again, 1 mark for the statement and another mark for the reason. Now, moving on to the next question. Is everybody happy with that? Okay, moving on to the next question matrix. They've asked us to prove that ON is half of MS. Okay, ON is this little line over here. I don't know how well you can see the yellow. And they want us to prove that it's half of MS. Anybody got any idea as to what rule or theorem we're going to use in this situation? It can't be proportionality intercept theorem, Luyanda, because we don't know that we have parallel lines. Remember, we can only use prop in theorem if we know we've got parallel lines. So we can prove that ON is parallel to PM. We will be able to do that, but prop in theorem isn't going to be what we would use. Anybody else? Okay, so here's a little hint for you, matrix. Ah, there we go, Swelihle. Well done, midpoint. Absolutely. Absolutely, because N is the midpoint of LN and NP. Also, O is the center of the circle. So what can we say about LO and OM? Why does LO equal OM? Precisely, Linda. Precisely, because they are radii. So we can use midpoint theorem in order to be able to prove this. Okay, so I'm just moving that up just a little bit like that, and I'm going to write underneath here. Okay, so now we've decided what we're going to use. What do we need to state? Well, first of all, we have to state that Ln equals NP given, and LO equals OM because they are radii. Therefore, ON is half PM midpoint theorem. Just going to move this up a little bit. Sorry, I know the picture's going to disappear. But they told us PM equals PS. That was given. So therefore, ON is equal to half PS. Sorry, MS. Hang on a second, what did I say? PM equals, oh, MS, not PS, sorry. I just made a typo there. Let me just fix my typo. There we go. Okay, so matrix, this is out of 4. I would imagine there would be a mark for those. You would have to make both of those statements in order to say that ON is half of PM. I would imagine that ON equals half PM midpoint theorem. There would probably also be a mark for that and a mark on this. Stating that PM equals MS, maybe there would just be one mark on LN equals NP given and LO equals OM radii, and then acknowledging that PM equals MS. There obviously isn't going to be a mark on the answer because that's been given to us. Okay, so I think that would be the most likely scenario in this case. Is that making sense, everyone? Can I move on to the next question? We've only got 10 minutes to go, and I just want to try and see if I can finish this with you. Is everybody comfortable with that? Is it making sense? Any questions? Thanks, Karabo. Thanks, Felice. Okay, well, if there's no questions, then I'm just going to jump into the next thing. This is question 8.2. And now we see the parallel lines. Okay, so now immediately when we see the parallel lines and triangles, we're starting to think about what you had said. I think it was Luyanda, that's right, proportionality intercept theorem. Okay, so they tell us in triangle ABC, K is a point on AB such that AK is to KB is 3:2. So let's put that in straight away. So they've given us a ratio. So 3:2. And what we could do is call that 3x and we could call that 2x because we don't actually know the length of line AB. Then they've told us that N and M are points on AC such that KN is parallel to BM. BM intersects KC at L, fine, lovely, and AM is to MC is 10 is to 23. So again, it's another ratio. They haven't actually told us how long the lines are. So AM over here is 10 is to 23. All right, so the first thing that they want us to determine is the ratio of AN over AM. So the trick to these questions is identifying in which triangle you are going to work. So in which triangle do you think they want us to work here, Matrix? Triangle. Okay, so remember, if we're going to use proportionality intercept theorem, we have to be working in a triangle where we have one side parallel to the last side of the triangle. So in this case, we can see that AN, which is the side over here, over AM, they are directing us, oh, that is so squiff. They are directing us to this triangle. Okay, so triangle AMB. All right, so can you see that AN over AM in this case is going to be equal to 3. AN is 3, so that corresponds with this 3 over here. Over AM is the whole side, so this whole side was 2 plus 3, which is 5. Okay, and then because we've used the proportionality intercept theorem, we would have to say prop int theorem, and then we must not forget to name the parallel lines. Okay, so NK parallel to MB. Okay, so very important matrix. If you do not state the parallel lines, they will not give you the mark for that. You can also say, there's another reason that you're allowed to use. It's gone out of my head at the moment. And then you don't have to name the parallel lines. But if you are saying proportionality intercept theorem, you must name the parallel lines. So 1 mark for the answer and 1 mark for the reason with the parallel lines. Is everybody okay with that? Are there any questions? Okay. So if we look at triangle AMB, we know that this side over here is also 3. And we know that this side over here is also 2, but it's not in the same. It's not definitely, AM is not the same length as AB. We can see that AB is a lot longer. So what we could do is we could call AN 3Y and we could call NM 2Y if we wanted. And then at least we've got a point of comparison between the two. We know that X and Y are going to be equal to something a little bit different, which we may need to calculate. All right, so the next thing that they want us to do is work out CL over LK. So CL over LK, which triangle are they directing us to? Always ask yourself, in which triangle do they want me to work? So CL over LK. There's CL, there's LK, there are your parallel lines. So that is your triangle. Okay, so here, I never finished that little bit off. Hang on. So here they wanted you to work in triangle AMB. In this question, they want you to work in triangle CKN. All right, so now this is out of 3, so there's obviously a little bit more that needs to be done in this situation. So CL over LK is equal to CM over NM. Oopsie, it's a bad N. M. Okay, and that is because of proportionality intercept theorem. In this case, LM parallel to KN. So now we're going to have to go and substitute. CM we know is 23. They gave that to us. Let's just move this up a little bit. And NM is equal to 2y. Right, so now that means we need a value for this y over here. They've told us that the whole of AM, or the ratio of AM to CM, is 10⁻23. So in other words, they have given us a way of being able to work out exactly how long side NM is. Okay, side NM represents what part of the whole? It is 2, so NM is 2/5 of 10. Does that make sense to everybody? So into itself once, in there twice, so NM is going to be equal to 4. Right, so in other words, what we've done here is we've calculated 2y, or NM, so this would be 23/4. Again, there would be a mark for stating what it was equal to, together with the reason, and then your answer. Actually, that was out of 3, so maybe you wouldn't have the mark there, but didn't have a prop in theorem. I think it would be for, definitely there would have to be a mark for calculating that that was equal to 4. This was given. Okay, are there any questions, Matrix? Luyanda, you've got a thumbs up. How's everybody else feeling? Is it making sense? Okay, thanks, Michaela. Cool, Swelihle. Cool, Isaiah. I'm glad. Thanks, Atom Corsi. Great. Okay, well, unfortunately, that hour went by so quickly. That's all we have time for. Thank you very much for attending this evening. I hope you found this useful. I'm going to hand you back over to Coco. Thanks, Matrix. Good luck.
Thank you so much, Lee.
No
that was pretty helpful. Okay, so I don't really have much to say on our side. Just remember, guys, if you have any questions for Lee or for Mara-Lise, who will be running our class on Wednesday, please make sure to either drop your questions in the chat on the app, or you can email them to Mara-Lise. I'm just going to pop her email into the chat real quick so you guys can either screenshot or take it down, and then she'll be able to help you guys, or she'll be able to relay your message to Lee if Lee's teaching the next class. Okay, and one more question. I know we had sent out referral links for the referral to refer a friend to come to the class. I just want to know if A, you guys got those referral links, and B, if any of you have invited anyone to come and join us for these classes. So you can just give me like an emoji, or you can type in the chat if you didn't get it. I just want to get a sense of who's gotten the referral link that should have been sent out. Okay. Did nobody get the referral link at all? Oh my word. Okay. All right. I'll then chat to sales, and I'll chat to the mentors, and I'll find out what happened, because you guys were supposed to get referral links that you could then send to your friends and they could come join us in this class. But that doesn't look like it's the case at the moment. But yeah, guys, that's all we've got time for today. Thank you so much for joining us. We'll see you guys again Wednesday at 6 p.m. this very chat. Okay, bye-bye, everyone.
Bye. Thank you.